Hi, math team. Thanks for showing up for your learning. In this video, we're going to look at the different varieties of completing the square problems that I'm asking you to complete. These three topics. These four topics. Oh, I'm asking you to do a lot of complete the square. Oh, but I reduced the numbers, so you only have to do two of this one, for example. So here we've been asked to rewrite this quadratic in vertex form. That's actually going to create some fractions. So that's a little harder than I thought they would give us in type 1. In any case, I would start by copying out the function on a whiteboard or do it in your head. If you can do these in your head, it's fantastic practice. But if you use paper, that's absolutely fine as well. Okay, first step is bracket these terms. It's not strictly necessary when a is 1, but hey, we like following a method. So then I take half of 7 and I square it and I add it and subtract it to this bracket in there. So let's do that on the side. I notice some of you do it right underneath, and that's ugly to me. It's ugly to do it underneath because that should be where I'm doing the problem. This is scratch work that I do on the side. 7 over 2 squared is 49 over 4. Okay, so I'm going to add 49 over 4 to both sides of the equation. If you said that's 12.25, you ain't wrong, but you ain't doing it in a pretty way by my reckoning. Just do 49 over 4 minus 49 over 4. Okay, now we recognize that that's a perfect square trinomial. That is x squared plus 7 over 2 squared. I made an error that many of you make. It's to keep that square inside the bracket. It's not there, it's there. That's correct. Okay, this is what we're looking to create, where we have a out front. A is 1, so we don't see it. X minus the x value of the vertex. So the vertex would be here at negative 3.5 or negative 7 halves. All right, now this one here can come outside the bracket. There's no a to worry about, so it just comes out as itself. Okay, so we're going to have minus 49 over 4, and this tends to lose some of you, but it really shouldn't. 3 is the same thing as 12 over 4. Yeah, it's the same. And if you're saying, yes, but Mr. Jennings, I don't like fractions. Well, stop saying that. And start saying something like, oh, I don't like fractions yet, but Mr. Jennings, he's starting to convince me that they're really useful, and I see that he works very efficiently with fractions, so maybe I should try and work very efficiently with fractions too, instead of being chained to my calculator like some medieval torture device. Anyway, this is going to be a minus 37 over 4 and done. Okay, so then you input this into delta math. X plus 7 over 2 and bracket in the right place, and then square it, and then subtract 37 over 2. 4 is 4. Submit the answer. Let's see if I made any mistakes. I might have. I was talking. No, I didn't make any mistakes. All right, so let's go back and try a harder type. But this is easier. Why is this type 2? Oh, because we have to state the coordinates of the vertex for type 2. Right. Okay. So I'm going to do this one in my head. I take half of 12, which is 6, and square it. So I'm going to be both adding and subtracting 36 from this equation. So my k value is going to be minus 13 minus 36, which is minus 49. Okay. So this will be minus 49 is going to be out there. Okay. And then we're going to have an x plus 6 and bracket squared. Okay, so my vertex will be at minus 6. Right, now I'm not going to show you that one, all the steps, but just to encourage you that yes, you can do these in your head, unless I made a mistake. I didn't make a mistake. Okay, let's keep going. All right, I also know, if you noticed, I changed the penalty. People were telling me they don't like the penalty. I still think it's good to have a penalty there, some kind of negative consequence, but I divided the penalty by 4. To make it easier on you if you don't like that penalty. It'll only hurt you once, and then it won't hurt you for the next 3 times. Okay, let's take a look when a is not 1. But this one's also easy. I wish they gave you ones that had more fractions, because I love fractions. Love me some fractions. With these, you're going to have y is equal to negative 8x squared plus 16x minus 3. And then you factor out the minus 8. You stubbornly factor it out of x squared minus 2x. Okay, so I factored it out of those two terms. I hope you can see that that's equivalent. And then I subtract 3. I take on the side. I do this work on the side. I take this b number of minus 2, okay? Do it on the side. Minus 2 divided by 2 squared equals negative 1 squared equals 1. So add and subtract 1 to this equation. This equals negative 8x squared minus 2x plus 1 minus 1 minus 3. Okay, that minus 3 just comes down. So I recognize that this is x minus 1 squared. I can quickly do that FOIL, my x minus 1 squared, and find that that's true. Or I can see that that number there is what goes inside the bracket with the x. It's going to look like this. Negative 8x minus 1 squared. This has to come outside the bracket. In order to do that, this 8 has to multiply it. Okay, so negative 8 times negative 1 is positive 8 minus 3. Someone likes Fibonacci. This is equal to negative 8x minus 1 squared plus 5. Jam it in there. Negative 8x minus 1 squared plus 5. Celebrate your wins. It's important. Okay, so that's how you do those. That's how you do all those. Yeah, there's only 3 varieties. Okay, so yeah, we definitely want to do more of these. So I'm not asking you to do 2 of those anymore. It's going to be 3. I was about to push 5, but I'm going to settle 3. Okay, everyone, best of luck, and hit me up with your questions if you have any questions. Bye for now. Oh, I didn't end the recording. Bye for now, everyone, and yeah, about the questions thing, come find me.